Hello, everybody, and welcome. I don't know you, but I found the panel very insightful, so thank you very much indeed. And thank you. And yes, to the next session, I have the privilege of introducing Andy Martin, CEO of Control Plane, and Matt Jarvis from SNCC, the most famous duo in the open source and conference community. And they will be talking about SBOMs. So please join me in welcoming these two gentlemen.
Thank you. So I see some folks in this audience who've clearly seen this talk before. So no surprises. Okay. So, yeah, like Francesco said, this is me. I'm one of the directors of OpenUK, as well as being director of developer relations at SNCC and various other things in the open source community. And this is your bit.
Hello, I'm Andy, CEO at Control Plane, where we do cloud-native security engineering for regulated industries. I work for the CNCF as a pro bono co-chair of Tag Security, where we help projects that are looking to graduate through the CNCF's open source sponsorship program by performing technical advisory and security reviews. And finally, CISO at OpenUK, where I help to sail the good ship, hopefully in the right direction for international policy as well. Written some things, and still very technical. I love the hands-on keyboard style. After you.
Okay, so just to kick things off here, let's have a quick primer on what an SBOM is for those who may not know. So here's some definitions. In its simplest form, it's this acronym for software bill of materials. And then we have this massive load of text from ntia.gov, which I'm not going to read out. And then here's an alternative definition, although it can be other things apart from JSON. But yeah, I think the point here is that really it's just a bunch of structured data about what compromises your software. One second. And you know, what makes them any more valuable than you know, we've got structured data about our software in lots of other places. You know, our package repositories are basically a set of structured data about our software. And what makes SBOMs, sorry Andy, what makes SBOMs any more important than any of these? Well, absolutely nothing really. It's all just software composition analysis. But that's not to say that SBOMs aren't valuable. They're a really important step in improving how we manage supply chain security by giving us a standard machine-readable way of distributing and sharing that information. So if I'm a developer, I can use the SBOM to understand the dependency tree of a particular piece of software. In the security team, I have a kind of library of things that my infrastructure has in it that I can analyze when the next big CVE comes along. But for SBOMs to really be effective, we need to consider a lot more than just the basic information that they've got in them. And how we create them, how we manage them, and how we trust them is the key to really defining that value. This is your bit.
Right. Right, so SBOMs are at a point in time. I'm just going to try and maximize my slide image. Which direction is this? There we go. Yeah, they're a point in time capture. So unlike a package repository's database, they represent only the moment that they were created. So it's critical that we think about the moment in time. There we go. When we're going to create them. Logically, it makes sense to create an SBOM at the same time as we're creating our software artifact, so when it was built or packaged. That ensures that the moment in time that we encapsulate our SBOM actually corresponds to the moment in time that the software was created, which means probably creating the SBOM in the build system. All right, that all kind of makes sense through our CI/CD, and considering it as an output of the build in exactly the same way as we might consider the executables and packaging. However, this somewhat depends upon what we expect our SBOM to contain. If it's point in time, then some of the information it contains could become outdated, temporarily inexact. So something like CVEs. a CVE could have been released for the package that we're using between the time that we've built the thing and distributed it to the consumer. We'll look a bit later at the way that SBOMs and their friends can encapsulate some of this information. So perhaps it makes sense to create an SBOM actually when we ingest the code into our system. So as the consumer on the other side of this packaging build question, in order to ensure that the point of time capture is when we acquired it, and so the information is more recent, this could mean regenerating an SBOM in much the same way as scanning tools already do. So as Matt said, software composition analysis, we're looking at the package definitions of the software that's consumed by our software. And these are the same class of problem when we start to use not only the outputs of software composition analysis for image scanning and identifying vulnerabilities, but we're now doing that with SBOMs, and they're run at different times. So we're cognizant of this in the way that we modeled the threats. But that also means potentially the point in time is when we deploy them to our production systems. So this question of recency and freshness of vulnerability association is key to what we'll talk about today. Any and all of these approaches have their own merits and trade-offs. But probably from a logical and ease of adoption perspective, it makes the most sense to create an SBOM at build time, and then to scan the SBOM to update any vulnerability data at point of use. Whichever way ends up being the best route for you, the most important questions of SBOMs are around trust. Yes?
Does it also not make sense to record what you're actually configuring when you deploy to the cloud?
Yes, so the question is, does it make sense to also capture the configuration at deployment time? We will get into vulnerability exploitability exchange data with its founder, the good Dr. Alan Friedman, later on. I haven't looked at the definitions, so I wouldn't like to misrepresent them. This would be generating an SBOM with standard tooling at different points. Yeah. So potentially, yeah. But then I would add a production deploy SBOM as well.
Yes. Okay, we'll talk later then.
Uh-oh. Okay. Right, so trust. Trust is fundamental to human and technological interactions, deeply rooted in authority, and of course accepted on implicit and explicit levels in our daily lives. In technology, the authenticity of the authors of software and hardware is verified through cryptography, and trust is extended to new producers in this way. This is much like having faith in a restaurateur's complex dish, its ingredients and safe preparation, ensuring that there are no impurities in the supply chain of the nutrition. This contrasts to other industries where shared responsibility models exist. Software lacks a trusted food standards authority to vet the entire digital supply chain safely, which means we need to extend our trust to every producer of software individually. Therefore, trust in SBOMs depends on the producer and its adherence to practices that lead to more secure software. Robust and trustworthy software, as we've seen with things like SolarWinds, really starts all the way back from the end user device, the developer, the build system that it goes through. So we would be checking for our SBOM food standards authority, developers, CI/CD, packaging infrastructure, the owner of the signing keys that we use to asynchronously verify those claims, guarantees that no other individuals have got access to those keys and can maliciously sign whatever they want, the underwriting of the security keys and the chains of trust associated with those, and security guarantees from a third party that guarantees CI/CD adherence to best practice, like we've seen with the OpenSSF scorecard and All-Star work before, and also the self-attestation to secure builds that Victoria was talking about in the fireside chat yesterday. So tech is a long way from the levels of trust that we have for food and other safety critical systems. As with many formats, there are parts of the standard that are mandatory and many parts which are optional. And many of the tools only really deal with the mandatory elements of the SBOM, which means that not all SBOMs are created equal.
I've got this. Mm-hmm. So there's an emerging set of tools that you can use to test the quality of your SBOM. These are some of them here. SBOM scorecard that was out of eBay. There's SBOM QS. from Interlink, and there's a whole bunch of other tools emerging in this space from organizations like NTIA. And this idea of quality in the world of SBOMs is kind of really highly subjective, because it's going to depend on what your organization cares about. And all these tools present their definition of quality in a slightly different way. But, you know, in general, what they're all doing is bringing back quality scoring based on different parts of the data that's contained in the SBOM. Things like, does it have full package URLs? Does it have the license information in it? So I think what's interesting about those kind of tools is that they really reflect what users care about in the world of SBOMs, because you know, they're subjective based on what people actually care about. And I think, you know, the kinds of outputs of these tools are likely to influence the development of standards and the way people interact with SBOMs moving forward. So this is just a quick example of this. So this is an entirely correct SBOM, meets the Cyclone DX specification. I've snipped it for brevity, but we can see that it contains information for each library along with the dependencies for each of those packages. Now, if we test that particular SBOM with SBOM scorecard, the overall score that it gives this is 77%. It's not very visible on this screen because it's in yellow. This was based mainly on the fact that there are no package licenses in this particular SBOM. There isn't a hard requirement in the spec for license information, but it's clearly seen as important because all of the quality testing tools that I've used all score for it. And like I said, you know, this is going to be a subjective field, so it's really down to your own organization which things are important here. But, you know, because all of our software as all of our software starts being shipped with SBOMs, we might imagine wanting to test the quality of our SBOM documentation as we ingest particular pieces of software. And one way to do this might be to use policies based on, you know, in our CI/CD system, and potentially gate on poor quality SBOM documents. And, you know, here we can kind of leverage existing policy tools like Open Policy Agent to build these tests into our pipeline. So here's an example of a Rego test that'll fail if the SBOM quality score from SBOM scorecard is less than 8. And if we run this test locally using convtest at the bottom, we can see that the SBOM fails to pass that particular policy. So given that we've got a lot of these optional fields and our tools may not deal with all of them, we can imagine that users might want to enrich their SBOMs to add extra relevant data, things that you actually care about within your organization. So perhaps we want to add that license information. Perhaps we want to have richer information about the components that are in that SBOM, who the authors of that software were, or even security vulnerabilities. And again, there's emerging tooling to do SBOM enrichment that lets us add other interesting data from different data sources. This is a tool called Parlay. I'm slightly biased because I work for SNCC, but this is an open source tool. And Parlay basically enriches SBOMs from a whole different variety of upstream sources. So it adds more detailed package data. It can do bring in the security scoring from the OpenSSF scorecard for a particular package, and it can also add vulnerability data from SNCC's vulnerability database. So if we go back to our SBOM example again, we can see that we've got that package data in there, but it's fairly minimal. Doesn't contain anything about licenses, which we know scored it down on the quality testing. And one of the sources that Parlay supports is this site ecosystem.ms, which provides a ton of open data about packages available via an API. And so we can, I've again split this slightly for brevity, but what we're going to do here is enrich this particular SBOM using that source. You can see at the top there, we're using Parlay to enrich that. And when we look at the new SBOM, we can see that it's tons richer about that particular package. Not only have we got license information in there, we've got a whole bunch of detailed information about the supplier of that stuff. We've got lots of references to external sites. We've got release dates and all sorts of tags and things there. And if we retest this enriched SBOM, we can see that we now score much more highly on that particular test, mainly because we've got our licenses in the SBOM. And another avenue for enrichment is adding the OpenSSF scorecard to our SBOMs. I know if you were here for the panel a minute ago, there were some discussions about OpenSSF scorecards. It's a pretty major project funded by the OpenSSF, which runs a bunch of checks on open source repositories for security-related data, community health licenses, all that kind of stuff. And these are machine readable and accessible via API. So if we look at enriching with the OpenSSF scorecard data, again, we can use Parley to add that. And what happens is we end up with this external references section, which is a link directly to the OpenSSF scorecard scores in JSON. And we can also see how we can add vulnerability data directly into the SBOM itself. In this case, this is using Snyk, but obviously there are a ton of different ways that you can use different security vendors to add that information. And we're embedding this directly in the SBOM, which is one of the forms that a vulnerability disclosure report in the SBOM world can take. There are actually a couple of different formats that I think Andy's going to touch on a little bit later in this talk. But putting them directly into your SBOM is one of the ways that you can do it. And again, we use Parley to enrich using the Snyk vulnerability database, and we can see that we've got a whole bunch of vulnerabilities there with all the details about that particular vulnerability. So in terms of enrichment generally, there's lots of possibilities for customization. If there were things that you particularly want to add to your SBOMs, you can extend Parley to do that, submit PRs. It's a subjective field, like I said, it really depends what you care about. But adding lots of this stuff in there can really add some depth into the data contained in your SBOM. And over to you again.
Thank you very much. Right, there's a Moxie Marlinspike quote, which I've never been able to find the attribution for, but it says that software is constantly evolving and moving, and any software that stands still dies. And of course, the case here is that when we consume dependencies, 0 days by definition didn't exist when we didn't know about them. So we always want to take advantage of new features. We need to constantly patch and keep our software dependencies recent. And of course, a company that doesn't ship features from a commercial perspective will fall behind its competitors, and therefore, unless there's an infinite money tree, will die. So we want to ship software. New software brings the risk of vulnerabilities. Slow software brings the risk of vulnerabilities. We need to keep moving, and there is a risk here. So can we use SBOMs to mitigate risk of compromise? And if we do, what are we risking ourselves? So, of course, SBOM compromise, and by this I mean manipulation, tampering, use of software that's either not there or extra, can lead to software implants, remote code execution, and a host of other cataclysmic events. These are, of course, present in software in general. This is nothing new, but it's important to note that when we are imbuing SBOMs with this huge extra dimension of trust that previously we didn't have a concept for, apart from maybe software composition analysis, not verifying them and trusting them leads us into a false sense of potential insecurity or security. So let's discuss VEX and VDR and their purpose. And it looks like we captured these images from Cinefilm back in the day. And the impact of running SBOM generators at different lifecycle stages and the temporal aspects of VEX and API-based integration. Okay, so software bill of materials is an extremely valuable tool, but doesn't explicitly distinguish between exploitable and non-exploitable vulnerabilities. A good example here is if we're consuming an OpenSSL library and we're not using the invalid cipher or the insecure cipher, should we still be able to use that library in production if we can prove that we're not using that cipher? So early adopters have stepped up to the plate. We heard a talk from Puerco about OpenVex yesterday. There are plenty of new standards to support vulnerability understanding in the software supply chain. VDR, CSAF, VEX, OpenVex. we can think of security scanners, so software composition analysis linked to vulnerability databases, as over-eager watchdogs. They'll sometimes bark even when there's no intruder. So imagine being alerted to a vulnerability that's already patched, not present, not executable because it's under an unreachable code path, or a function in a library that's just not called by the consuming software at all. To teach our watchdog some new tricks and cut through the noise, we can feed VEX data from the software supplier into our scanning processes. This data indicates that a trusted party, ideally the vendor or producer of that software, has verified that the software is not exploitable by a specific CVE. Now, in Puerco's talk yesterday, the Kubernetes core are doing this with 2 different feeds, and this is still an unsolved problem, but there's a call to action. If people want to be involved, then up at the end of the slides are the places you can look at contributing into Kubernetes to try and start solving this trust issue, to paraphrase. So the triumvirate of vulnerability management as it stands today, VDR, VEX, and OpenVEX. So vulnerability disclosure reports are crucial resources with a list of known vulnerabilities published by vendors. However, it's not programmatically or machine consumable.
VDR, there are exactly 126 words that have ever been written about VDR. It's not a thing.
Okay.
In fact, the name will probably go away. So
From the horse's mouth. Right, excise this portion of the slides. I will take a blotter to it. Okay, well that's wonderful because it's...
That's a fine idea.
Where it negatively differentiates itself is an absence of programmatic interaction. So wonderful. It's not mentioned any further in the talk, fortunately. What we have then is VEX. Vulnerability Exploitability Exchange Formats, and thank you so much for making that impossible to say. I've practiced in the mirror many hours.
It was a temporary name.
Oh, and that always happens, doesn't it? Right. So yes, Vulnerability Exploitability Exchange Formats takes us a step further, and OpenVEX then gives us an interoperable and embeddable version which is able to interact between the different slightly competing standards here. Okay, so with that, let's now look at what we can do as an attacker to subvert the SBOM process for an organization that is building their software supply chain security program on SBOMs. There are 2 classes of threat to an SBOM, malicious and accidental. Malicious threats are deliberately introduced by attackers with the intent to cause harm, for example, injecting malicious code into an SBOM, creating a fictional release with a tampered SBOM. On the flip side, accidental threats are, of course, unintentionally added due to errors or omissions in the composition of the SBOM. For example, incomplete or outdated data, leaking confidential information, pointing to internal APIs. Let's look at how and where these can happen. So again, we care about where the SBOM was generated and to what depth. Closed source compiled software may have components that can't be identified with software composition analysis or introspecting into a compiled binary, and so we must generate these at build time. But then they can't be validated unless the consumer has the source to rebuild everything, and we have a trust issue that needs resolving from a vendor perspective. Open source software can be scanned when it's ingested into an organization. So, Zero Trust says trust but verify, but we still run perimeters, we still have VPNs. This is part of a layered security approach. So ingesting software into a large organization used to involve somebody doing a line-by-line code review. At this point, we're a little bit faster, but still, we're taking software into an internal repository to make it available to our developers from a list of secure internal software. So at that point of ingestion, it's worth scanning the software. But then it's just software composition analysis again, with the additional hurdle of having a third party that we have to trust, not to tamper with it, or to make mistakes in their SBOM. So we're not replacing software composition analysis, but we can make additional verifications to it. Can we make it more complicated? Yes, indeed we can. And this is where we'll pull up some threat models. So various places that we can get in and cause problems for the software supply chain, for SBOMs.
In 1 minute, Andy.
Yeah, wonderful. I think we started a moment late and we'll probably overrun because there's a number of slides left. So, local compromises are, of course, problematic. Everything from that point onwards then becomes compromised, and a signed and valid SBOM for an application with malicious implants or vulnerabilities provides a false sense of security. There's no vulnerabilities in the dependency chain, but the application has been compromised in the first place, or the package. The source repo, if the source repo is compromised, people can inject code. But then we're looking at the scorecard level security here again. This potentially gaining control forces the producer to generate a vulnerable version unknowingly. Dependency confusion at this stage. The build stage, we've got incomplete SBOM generation, compromised tooling, code injection, confidential data leakage, version regression, weak hashing algorithms, data mismatches, provenance manipulation, and outdated SBOM content. There are controls for many of these things. The approval and release, the tampering of metadata itself, signing an SBOM with compromised keys, so it doesn't actually represent what is internal to it. The package, we have fictional dependency releases, social engineering attacks, where we're manipulating people into disclosing their credentials and then taking actions that compromise the SBOM in a previous step. Man-in-the-middle attacks, where, of course, we're relying on things like signing and TLS. Package assessment, lack of contextual verification, so not actually checking the hashes and metadata or additional information, but just blindly trusting it. Compromised or outdated threat intelligence. If we've got to walk over an air gap to upload our CVE data all the time, well, that zero-day frequency and recency is correlated with the sneakerware, how quickly we do that. And then transitive dependency proliferation. SBOM graphs are generated one of two levels of depth, either primary dependencies or the entire transitive dependency tree. That is huge for complex applications, leading to essentially alert blindness and an inability to prioritize for most critical patches. And then finally, we do everything right as a producer, everything comes into our organization, and then, again, the SolarWinds style, a threat actor has infected our validation or ingestion infrastructure, and then it doesn't matter what's been done upstream, because if the threat actor has control there, the SBOM that is not worth the bits it is flipped on, or similar. Right, so you may recognize this from Salsa. It's another view of the software supply chain we just threat modeled. In the complex world of software security, establishing this consumer-producer trust is paramount. So trust starts with a basic threat model that considers vulnerabilities at every stage, be it a compromised upstream, issues in transit, or during the ingestion process. And we'll extend this a little bit to classify the threats. Those are the things that I just went through, placed in order. I am actually talking to Mr. Michael Lieberman about getting these upstream into some of the work that the OpenSSF is doing. They're classifying the threat actors, and it is just on me to get my posterior in gear to hurry that up. Right, so pre-build, can you imagine what could go wrong from a compromise perspective here? We will not go into this in too much depth. The slides are available. A reasonable amount. And this is where threat modeling is so valuable, because it gives us an abstract view of the system. It enumerates all the critical, catastrophic, worst-case scenarios that could occur, and then we say, what is the actual risk? So the impact of this, give it a score out of 5. The probability, again, another score out of 5. Multiply those together. You have an abstract risk score that you can then order all the threats by. Then you have a list, and you can say, well, that threat is not actually something that we care about, so let's descope that one. Or you could say, we don't actually want to guard against nation-state level threat actors, because the five-pound wrench technique renders that impractical for us, so we'll descope that one as well. Then you end up with a list of threats that the organization genuinely cares about. And then we can apply controls to them, and that is the iterative process of threat modeling. I will actually be talking about this with Ala Jubri from VMware at KubeCon in Paris next month, if people are interested further. And then, of course, this is relevant to the entire build process. The concept of ephemeral builds, of course, is necessary to secure and harden the generation stage. And then, did we do a good job? So once we've generated that threat model, We can then map it into an attack tree, which is, as an attacker, how would I escalate my permissions to reach an end state goal, which is an existential threat to the organization? And framing things as existential threats then makes the organization sit up and listen, right? We're still selling security to stakeholders. And as someone in the OpenSSF used to say, turning money into security is the dark arts of what we're supposed to be doing here. So convincing stakeholders that there is a genuine problem and drawing that path of escalation to rationalize and quantify what an attacker would be doing inside an organization. There are loads of people doing excellent work around this. We've got the CNCF Tag Security, where we do some work under the Cloud Native Computing Foundation. The OpenSSF does a huge amount of work under the Linux Foundation as well. We've got Frisker, which is a secure build exemplar system based on Tecton chains. It has signing, it integrates Sigstore, and all that good stuff. And the Software Security Supply Chain Best Practices document from Tag Security outlines a lot of this as well. Okay, over to you, sir.
I mean, I know we're slightly over time now, but I think it's pretty clear from the threat model piece that Andy just put up there that SBOMs are only really useful as part of a larger security system that's based on trust and attestation. And there's lots of points where any failure to deal with trust can really make your SBOM become completely worthless. You know, I do know of people who are literally collecting SBOMs in folders and thinking that that is a security practice. But yeah, so I think that's what we were kind of saying. SBOMs are super, can be super useful, but they're not a magic bullet that's going to solve any of your security problems. You've got to treat them as software, think about their life cycle, think about how we create, how we manage them, and how we verify them, and show them some love, stick some stuff in there, think about the things you actually care about.
Matt, Andy, love this talk. Thank you. We always say that the SD in SBOM does not stand for silver bullet.
Nice, I like that.
I do have a question on sort of the enrichment and layering, which is there seem to be two directions we can go architecturally. One is create bigger and more holistic SBOMs, and the other is focus on linking to different sources of data, but trying to make things modular. One, do either of you have a preference? And two, do you see us heading one way or the other?
I think, you know, I mean, Parlay is obviously kind of a proof of concept thing about enrichment, you know, that Gareth Westgrove originally put together. I think the idea of keeping things modular is certainly, you know, is always preferable to anyone who's an engineer of any kind, because it's very easy to end up with these SBOMs being gigantic, as you know, anyway, right? I mean, even just the dependency trees and all the rest of it can be huge. I think if we consider all these things as separate documents, we do kind of multiply the problem about the life cycle of these things, you know. So there was one argument about the less documents is better because, you know, you only have to consider the life cycle of one thing as opposed to, oh, now I need to consider the life cycle of 10 things and they all need to be signed. I think we had some interesting conversations the last time Andy and I gave this talk about how the idea of verified and signed SBOMs, once you start enriching them, you've kind of created another, you know, you need to consider other chains of trust there as well, because you're now putting other stuff into that document that at one point you accepted was this signed, sealed, delivered thing from somebody else. So yeah, I don't think I answered that question very succinctly.
It maybe comes down, and I think there's two parties. On the one hand, you've got sort of fully reproducible, deterministic, Nix-focused people who love Merkle trees of everything. And on the other hand, you've got people who just want to ship software, essentially. And I'm not saying that there's no intersection between the two, but there is a mindset that from the Nix crew, if we're going to generate an SBOM, then everything should be hashed. The component vulnerability data should be externally referenced and not codified into the document itself, because they see that as a build time attestation to the composition of the artifact that is immutable, and they're done. On the other hand, you've got people who are happy to maybe not even pin to a semantic version fully and say, well, actually, I'm going to keep on pulling, and I trust Semver to do the work there as well. In that case, I think from that perspective, you are doing a snapshot, and the vulnerability data makes a little bit more sense because you're building against the version that you're pulling and actually running that vulnerability data on what's been installed, not necessarily on the contents of the package JSON for an NPM case. So that's not an answer either. Very proud to say.
Thank you very much. On
but
that note, I think we have to leave the stage.
that's probably sensible, and lunch is served at some point. So
thank you very much, folks.